Greetings, Mr. Kolazar's class. Now we're going to look into putting the gas laws that we've talked about together. So we call that our combined gas laws when they're combined together. Now our relationships are still between pressure, volume, and temperature haven't changed. So pressure and volume inverse to each other, meaning one goes up, one goes down. And pressure, temperature, pressure and volume are still directly related. One goes up, the other one goes up. So to combine them all together, pressure 1 over volume 1 equals divided by temperature 1 equals pressure 2, volume 2 over temperature 2. This equation is in our gold packet. Now we can rearrange this equation by simply dividing or multiplying this side by T1 to move T1 to the opposite side, and multiplying this side by T2 to move T2 to the opposite side. So notice pressure 1, volume 1, temperature 2, pressure 2, volume 2, temperature 1 might be another way visually to see the equation is to write it this way. Now, what we've seen so far is if we hold one part constant. So if we hold one part constant, this would be the Gay-Lussac's law, where volume is held constant, meaning if volume 1 is the same as volume 2, we can remove it from the equation. And we now have pressure 1 over temperature 1 equals pressure 2 over temperature 2. Or, if we hold temperature constant, we're going to have Charles' law. Boyle's law. Where temperature is constant, so it was removed from the equation. Pressure 1 times volume 1 is pressure 2 times volume 2. And then our third one, pressure remains constant. Now we have Charles' law, where if pressure remains constant, it can be removed from the equation. Volume 1 over temperature 1, volume 2 over temperature 2. But what we're going to see is if we change two things, pressure, volume, or temperature, how does that third one change? So we can actually change two variables at the same time with our combined gas laws. So it says if the temperature of a gaseous cylinder is shown increases to 30 degrees Celsius and a pressure of 1.2 atmospheres, so we've changed temperature and pressure, will the piston move up or down? So we got to find out which direction this piston is going to go. Is it going to go up, or is it going to go down? So we started off with an initial temperature of T1 and moved it to a second temperature of T2. Now remember, temperature has to be in Kelvin, so add 273. So 273 plus 0 is 273 Kelvin. And temperature 2, if we add 273, gets us to 303 Kelvin, would be our T2. Now our pressure 1 is 1 atmosphere was initially at, and volume 1. And we've changed the pressure from 1 to 1.2 atmospheres. So the pressure is changed and the temperature is changed during this problem. So our combined gas law, saying that we could go P1 V1 over T1 equals P2 V2 over T2. Now we're going to solve for volume so we can find out if the piston is moved up or down. So if we're solving for volume, V2, we're going to rearrange our equation to move temperature and pressure over to the other side. So our equation, P1 V1 over T1, now T2, multiply this side by T2 to get it over to the other side. T2 would move up top. P2 we need to divide by P2. P2 would go on the bottom to give us volume 2. So we've just rearranged our equation. They're still the same, but we've rearranged to solve for volume 2. So to plug in our information, our pressure to begin with. So pressure 1, 1 atmosphere, times volume 1, 30 milliliters. Temperature 2 is on top, times our 303 Kelvin, or 303 Kelvin. That should have been 1 atmosphere. Divided by temperature 1, our initial temperature, 273 Kelvin, and pressure 2, what it's changed to, 1.2 atmospheres. Now if we look for a moment, atmospheres will cancel atmospheres, Kelvin will cancel Kelvin, and we're left with milliliters. Numbers on top multiplied, numbers on bottom are divided, and it turns out that it's about 27.8 milliliters is V2. Now our initial volume, volume 1, was 30 milliliters. So if we look at the difference between those two, if we started at 30 and went to 27.8, the question is, do we move up or down? So we must have that piston move down or to shrink in volume. So combined gas laws, what we've done is we've combined two variables to find out how the third one is changed. That will be the end of our combined gas laws part. You can continue in now with our combined gas law problems, either changing pressure and volume to find temperature, temperature and volume to find pressure, or temperature and pressure to find volume.